Oh, hello everyone. I'm Shiv. Let's start further today. Today I will teach about the AC circuit. How can you solve the problem about the AC circuit? How to find the impedance and what is the happening at a resonance. Okay. Let's try. Started from question number first. Consider the following circuit. Here the input voltage is 10 cos t, and this one is the RLC series circuit, but there is a mutual inductance is there. Which one is independent inductance is 4 Henry and 8 Henry, but there is a coupling coefficient also there, which is K. Then we have to consider that one and find the value of K for the circuit at resonance condition. Okay.
Yes, sir. Yes, sir.
Yes, sir. In this case, first of all, you know about the series resonance circuit. X is equal to XL. For the resonance, X is equal to XL. But here is 2 Henry or the couple inductor. Couple inductor, it means there is a 2 inductor winding at single core. Okay, that's why there is a coupling capacitance also there, which will affect the mutual inductance. In this case, I taken as this one is equivalent, not XL only. Then what is the equivalent inductance in this case? There are two conditions L equivalent for the series connection, L1 plus L2 plus or minus 2M. Okay, if if the if the two inductor connected in additive polarity. Additive polarity, it means where the current is entered at same position, dot position, and this is also entered current. If that dot is here, in this case this will be a 2M plus up 2M. But in this case, the current is entered in one inductor in the positive side, and if we take positive for the entering current, but the dot polarity in another side is currently leaving from the negative side, not the same side. If dot is here, both are both inductor current is flowing in same position. It means additive polarity, but here dot is opposite. Once is entered in with dot, and another is leaving from dot current. That's why there is a negative. Then equivalent is L1 plus L2 minus of 2M. But L1, L2 is given, but you don't know about the mutual inductance. Only coupling coefficient is there. K. The relation between the coupling coefficient and mutual inductance is M is equal to K root of L1 L2. Root of L1 and L2. Only L1 and L2 is given in this question, which is 4 Henry and 8 Henry. Then you can put the value K root of 4 into 8. This will be a 32. K root 32 is the M. Then what is the L equivalent? L equivalent is equal to L1 plus L2, 4 plus 8 minus of 2K root of 32. It will be 12 minus 2K root 32. This is the L equivalent. Sorry. Okay.
Sir, how to identify L1 plus L2 minus 2M?
Yeah, that's one is the if this dot is given, if the current entered from dot from for the both inductors, current is entering from dot in both inductors, and that time you have to take it as a positive because of the both are the additive polarity, both are generate the flux at the same condition and same direction. In that case, flux will be added. A flux added, it means inductor is increases additive polarity. If the current enter from dot, if dot is here for second inductor, that means current enter from dot in inductance 1 and current enter from dot inductance 2. In that case, it means flux will be adding because of the flux direction is same for the both inductor. That time you have to taken as a positive for the mutual inductance. But here current is entering from dot from one inductor, but second inductor have current leaving from dot, not entering from dot. In that case, flux will be opposite direction. That means the flux will be reduces, which will reduce the total inductance. That means minus of 2m.
Thank you,
Thank
sir.
you. Welcome. Okay. Question number first. I start from question number first. Xc is equal to X equivalent. Xc you know about this one, j omega c. XL is equal to j omega L equivalent. Here what is omega? Cos t. Cos t, it means there is a 1 only. You know about the expression, this will be cos omega t. It will be that's one. If omega is equal to 1, that means this will be cos t. Omega is equal to 1, you can put the value at omega is equal to 1. Okay. Take the magnitude for the both, because both are the equal, that means magnitude also equal. 1 upon omega is equal to 1, 1 upon c is equal to L equivalent. That means L equivalent is equal to 1 by c. Omega is equal to 1. 1 by c. C is 1 by 8 in this case. That's why 1 divided by 1 by 8. This will be 8. Equivalent inductance is 8 at resonance condition. And this will be given as 12 minus up to k root of 32 from the circuit. This will be 8 minus 12 is equal to minus up to k root of 32. This will minus 4. Then what is the k? K is equal to minus 4 divided by a 2. It will be 2 by 32. 2 by root of 32. We have to calculate this one. This will be 0.35. Coupling coefficient is 0.35. In ideal case, coupling coefficient is 1. Is always less than 1. Coupling coefficient is always less than 1 in practical cases. It means only 35% of flux is linked in both the inductors. It means 0.35. It means only 35% of flux is linked from in both inductors. Okay. Let's for the next question. In the circuit below, which of the relation below need to be held to transfer maximum average power to the right side of the terminal A, B? Here is a problem from the maximum power transfer. Maximum power transfer, you know about this. Input impedance should be equal to the load impedance. Source impedance should be equal to the load impedance. In this case, what is the source impedance? Source impedance is resistor only, which one is 50 ohm. Remaining thing is load in this case, because of the terminal is given A and B and asking about the power transfer to the A and B. In this case, you have to consider these are the load impedance and this is the source impedance. And you know about the for maximum power, Z load should be Z source. If load is varies, if load is vary, let's just C. C is variable and L also given. Not mentioning, only register is given 100 ohm. Remaining thing is varies, varying. That's why load is varying. Then load should be equal to the source. Source is the 50 ohm. Then you have to calculate the load impedance. Then we have to find the impedance at AB. What is the total impedance of this circuit? It means we have to take a point, inductor and a capacitor parallel with the resistor, terminal A and B. We have to find the impedance AB. It should be equal to the source impedance. L, this will be j omega L. C, it will be j1 upon j omega C. This resistance R is given as 100 ohm. In this case, you can see these are parallel combination, and with this parallel combination, inductor is in series. Then total impedance you can say as j omega L plus this one series with this parallel combination, 100 parallel with 1 upon j omega C. This will be j omega L plus this will be 100 into 1 upon j omega C divided by of 100 plus 1 upon j omega C. This is parallel combination. You can take LCM in denominator as j omega C. That means this will be j omega L plus this will be 100 divided by of j omega C divided by of 100 j omega C plus 1 LCM of j omega C. J omega C is cancelled out, and this will be j omega L plus of 100 divided by 100 j omega C plus 1. Actually, you can say this will be j 100, right? A imaginary term first, j 100 omega C. As a complex term, we have to simplify complex term one side and real term is another part. We have to take this two part. Then how can you reduce the imaginary part in denominator? By multiplying up negative term of this one. This should be written as 1 plus, so can be written as 1 plus j 100 omega C. We have to take negative of this coefficient, 1 minus of j 100 omega c divided by of 1 minus of j 100 omega c, j omega l plus we can multiply of this one 100, this will be 100 minus of j, this will be 100 square omega c divided by of, you can say this will be a plus b, this will be a minus b, that means a square minus of b square, a square is 1 minus this one square, j square into 100 omega c square, j square is minus of 1, that's why this will be positive, j omega l plus 100 minus of j 100 square omega c divided by of 1 plus 100 omega c whole square. You can take a part wise, this will be imaginary part at one part and real part other. This is 100 divided by 1 plus 100 omega c square is the real part only in this case, and remaining things is imaginary part, that's why real part is here 100 divided by of 1 plus 100 omega c square, this will be a plus of j, remaining part is omega l minus of 100 square omega c, this will be divided by of 1 plus 100 omega c square. This is the ZAB. It should be equal to for maximum power. ZAB should be equal to source impedance. Source impedance is only in resistor, which will be 50 ohm. Is given in the question. Then we have to take the magnitude of this one. Means magnitude of this one should be equal to the 50 ohm. How can you find magnitude? It's a real part square, root of real part square plus imaginary part square. Root of real part is 100 divided by of 1 plus 100 omega c whole square plus imaginary part is omega l minus 100 of 100 square omega c divided by of 1 plus 100 omega c square. Real part square plus imaginary part square, it will be equal to 50. You can square the both side, then this will be 100 square divided by of 1 plus 100 omega c square plus this will be omega l minus of 100 square omega c divided by of 1 plus 100 omega c square. This is equal to square of 50 is 2500. Okay. In the question given the combination, that given the direct value, omega c is 0.1, omega c is 0.1, omega c is 100, 100. Which one can you choose for this one? omega c and omega L is given. Option A, check the option A. In this condition, omega s is given 0.01. If you put the 0.01, that means omega L should be equal to 50. Then in this case, the first option is correct. If this is not 50, that means this is wrong. Okay, then after you have to put the omega c is equal to 100. In this case, you have to check these two. If which one is correct. First of all, check this one at omega is equal to 0.01. These are the two options. It should be or 50 ohm, 50 or 200. Put the value omega is equal to 0.01. That means if omega is 0.01, it means 100 multiplied by 100 is equal to 100 into 0.01. It will be 1. That is 1 square is 1 only. 1 plus 1 is equal to 2. This will be 100 square. 100 square divided by up. This is the whole square also here. 100 divided by this one. This will be a whole square. Here. That's what 100 divided by up 2 whole square. 1 is 2 plus this will be omega L minus omega c is 0.01. This will 0.01 into 100. 1 into 100 is 100 divided by of 1 plus 1 is 2 square is equal to 2500. This will be 50. 50 square is 2500 plus this will be omega L minus 50 whole
Sir,
square.
sir, in the imaginary part, 100 square into omega c, right?
This one is 100 square into omega c.
Yeah, it's then how you put 100 divided by 2?
Okay, this will be 100 square. It means 100 into 100 into omega c 0.01. This will be 1. 100 into 0.01 is equal to 1. That's why 1 into 100 is 100.
Yeah, okay, sir.
Yeah. In this case, you can see 2500 is cancelled out in both sides. This will be omega L minus 50 square is equal to 0. That means omega L is equal to 50. And omega c is equal to 0.01. This is the first option is correct for this. Omega c for the omega c 0.01, omega L is equal to 50. So given in the option first. If this has not matched both 50 and 200, then you have to check omega is equal to 100. Okay. Simply take the terminal. Where is the terminal given in the question? Terminal A and B is given. That means the all thing is behaving like a load. And for the maximum power, load should be equal to the load impedance should be equal to the source impedance. There are many type of the load actually and source both. There are many conditions. Suppose condition number first for maximum power. The circuit wave looks like that. Both are in, this is a RL, this is RS. Suppose this is a BS. In this case, P max for P max for maximum power, RL should be equal to the RS. You know very well about that. Load resistance should be equal to the source resistance. Second condition, suppose this will be RS, but here is RL load. RL and XL. This is the load. In this condition, we have to put the load impedance should be equal to the source resistance. That means this will be RL square plus XL square is equal to RS. In the question, maybe this is not vary or maybe this one vary. Anyone, maybe chances anyone is constant, another one vary. Resistance is constant, inductor is vary, and many chances is inductor is constant, resistance is vary. If the resistance is vary, inductor is constant, it means not that RL is equal to RS. There may be confusion. Suppose this one is the constant and this is the vary, but both are the load, represent the load impedance. That means same formula we have to use. In this case, you can't say that RL is equal to RS. This is not correct because of the load impedance should be equal to the source impedance. Okay. Suppose third case. RS, XS, RL, XL. This is
Sir,
the
in the second case, RL equal to RS into X, sir.
RL is equal to
RS into X.
into X.
That's what I am asking.
No, no. How can you multiply the X?
No, you mentioned that is into mark.
No, no. I mentioned this one is not correct. This one is correct, not a X.
Okay,
Don't
okay, sir.
confuse that. This one is incorrect. This one is correct. I mentioned that. In this case, you know about the load impedance should be equal to the source impedance. Okay. But sometimes there is a capacitor, then you have to use the conjugate of this one. That means this both are it will cancel out. Then current is high. When current is high, then current is flowing to more. If the RL is mentioned, that means the load should be equal to the source because of the RL is not negative. XL is can be negative. If the XL and X is not mentioned, only impedance mentioned. Okay, like that. Only impedance is mentioned as ZS and this is ZL BS. For P maximum, in this case, if this one is varying, then ZL should be equal to the ZS conjugate. Okay, for the maximum power transfer. Is it right? If ZL is not mentioned, what is ZL? RL load or RC load. Here you can't say na RL load or RC load. In this case, we have to use the conjugate of this. Okay, but in this case, as mentioned RL and XL, that means this will be RL square plus XL square. It should be equal to the RS square plus XS square. Okay, this is a four condition. In this case, anyone can varies, and you have to check like that. Okay, in case of impedances. Next one, determine the resonant frequency of the circuit seen from the terminal A and B. And B is given. You have to find the resonant frequency for this. The series RLC circuit, but capacitor have a resistance parallel with this. The simple RLC circuit, you know about this one, resonant frequency 1 by 2 pi under root LC. But here our resistance is added parallel to the capacitor. That means this is terminal A and B. ZAB is here, 4 ohm. This will be J omega. Omega is not here. This will L is 4. This will be 4 omega. 1 upon J omega C. C is 1. It means 1 upon J omega. This is the resistance is 1 ohm. Okay. What is ZAB? In this case, you can say this is the series combination. It means R plus J omega L. If you take this one is the R1, this one is the R2, this one is J omega L, this one is 1 upon J omega C. This will be R1 plus J omega L plus parallel combination of RC circuit. It means this is R2 in R2 1 upon J omega C divided by of R2 plus J omega 1 upon J omega C. Put the value of all thing. Then ZAB R1 is 4 ohm. This will be J 4 omega plus this will be R2. R2 is 1 ohm. 1 divided by F. If we take a LCM, this will be 1 plus R2 omega C. This will be 1 plus J omega C is equal to 1. R is 1. It means 1 upon J omega only. We can take a LCM, then after find the imaginary part, or you can simply multiply up 1 minus J omega to remove the denominator term complex C. Remove the complex in denominator term. This will be 4 plus J 4 omega plus this will be 1 minus of J omega divided by of A minus B, A plus B, A minus B. This will be 1 square J omega minus of J omega square minus of J square is equal to plus 1 into this will be omega square. Z will be 4 plus J 4 omega plus this will be 1 word plus omega square minus of j omega divided by 1 plus omega square. Take the part of the imaginary ones and the real part is another together. This one plus of j, take a comma, this will be 4 omega minus of omega divided by 1 plus omega square. Now at a resonance condition, at resonance imaginary part is 0. The part become 0. What is imaginary part? This one is imaginary part. It means 4 omega minus half omega divided by 1 plus omega square is equal to 0. This will 4 omega is equal to omega divided by 1 plus omega square. Omega omega is cancelled out. This will be 4 plus 4 omega square is equal to 1. 4 omega square is equal to minus 3. Omega square is equal to minus 3 by 4. This will be minus of 0.75. What is the omega? Root of minus 0.75. This will be j 0.86. Actually, this is not a real part. This is an imaginary part. Frequency and time never imaginary. It will be a real part. That's why this can't be a frequency, resonant frequency. In this case, you can't determine the resonant frequency. It means in the circuit there is no resonance. There is no resonance in this condition. But if you see the option, if you find this one is given as omega is equal to minus, or you can say this will be j root 3 by 2. From here, na, you can see if you take a magnitude, then first option is matched root 3 by 2. But this one is incorrect. Here the frequency at resonance is imaginary part. It means there is no resonance in the circuit. There is no resonance frequency. Okay, that's why option D is correct, not A. You have to careful about that. If there is a positive term, there is no imaginary term. That means there is a resonance frequency. But here is imaginary term. That's why this is not a resonance frequency. No real value. Okay.
Yes, sir.
Next one.
Sir, actually, I feel subject is very tough, sir.
No, no, no. How?
Why? Because I think in the 10th or ninth week assignment is nothing but operational amplifier, right?
Yes, yes.
I am not attending your video lecture due to my some personal issue. So,
Okay,
but
okay.
it's very difficult, sir. Operational amplifier. So, really, what can I do in the examination?
You just you can follow the lecture notes also now if you have done time enough to watch the
Yes,
all
sir.
video, then you can refer to the lecture notes only. If you take the lecture notes, then I clearly mention step by step. I would not never, I never skip the step also. I solve all the questions step by step. Then you can understand better there from there.
Sir, as of now, only six assignment solutions only we received.
Yeah, it will
The
within
remaining,
within 1 or 2 days it will be all.
yeah,
Given
okay,
to you.
sir.
Yes. Okay, I take a revision class on 16. You can join. I think day after tomorrow I have taken the revision class for all the system.
Okay.
I
Yes, sir.
I can take as a example for the amplifier also.
Okay, sir.
Yes. Next question: the current I in the figure is simple AC circuit and find the current. Okay, this circuit, two sin t. Actually, if the magnitude Vt is written as Vm sin omega t plus theta. This type of circuit is written voltage source. Then in this case, you can replace this one is Vm at angle theta. You can write this one just like that. It's also 2 sin t. Both the sources are same. This will be 1 ohm. This is also 1 ohm. 1 Henry it means J 1. 1 farad is 1 divided by F J1. Okay. This will be 2 sin t. 2 sin t is written as 2 at angle 0. This is also written as 2 at angle 0 because of there is only sin t. Okay. That's why here angle is theta, but here angle is 0. That's why I written as 2 at angle 0. You can take a node voltage V here. Because of this, all three are connected. At this node, I have taken as a node voltage V. Then use a KCL. I take as the KCL. By KCL at node V. What is the KCL? It means whole voltage V minus of this voltage divided by ohm, this current, this current, this current, and this current. You have to take it. You have to take all of things. Then if this current will be V minus of voltage, this voltage divided by of resistance. This will be voltage minus of 2 at angle 0 divided by of 1 plus this current V divided by of 1 plus this current same voltage divided by of J1 or J you can say V divided by of J plus V minus of 2 divided by of J 1 by J. V minus of 2 at angle 0 divided by of 1 divided by of J. Because of C this will be 1 by J equal to 0. All the current at their node is equal to 0. Algebraic sum is 0. We can simplify this one. This will be V minus of 2 at angle 0 plus of V. We can write this one with Vj or Jv. If you multiply of j, upper side, the upper side is j, downside denominator is j square. J square is equal to minus of 1. That's why 1 by j you can always written as minus j. This will be minus of j. This will be j multiplied by the upper side. This will be jv minus of 2 j at angle 0 is equal to 0. This jb cancel out. V is 2v. This will be minus of 2 at angle 0. This will be minus up to this j is provide the 90 degree of angle. Okay, because you know about this one is a real part, this is imaginary part j. Difference between these two is 90 degree. That's why written as real part plus of j imaginary part. Difference between these two are 90 degree. That's why anywhere if j is means this one include the angle is 90 degree. Where minus j is there, this one include as minus 90 degree, or this one written as 1 by j. 1 by j is include the 90 of minus 90 degree angle. Okay, or same thing you can say here 2 at angle 0 you can simply to written as 2 minus of this one is 2j is equal to 0 from this one. You can write this one also. This 2b is equal to 2 plus 2j. 2 is concealed common from both left and right side. This will be 1 plus j. 1 plus j. How can you written as 1 plus j? Magnitude of this one 1 square plus 1 square. Angle of this one imaginary part is 1, real part is 0. This will be tan inverse imaginary part 1, real part 1. This will be of root 2 at angle of 45 degree. The terminal node voltage is 2 root of 2 at angle of 45 degree. Then what is the current? Current you know about the V. This current is asking in the question here. V divided by F 1 ohm resistor is same as V divided by F1. V is root of 2 at angle 45 degree. This thing you know about, this one written as root of 2 sine t plus 45. Okay. In the question mentioning this like that 2 sine t or some theta also, then simply you can write this thing like that V at at angle theta. Here a zero angle no meaning of 0, that's why you can written as 2 also. No need to write the angle, only you can write a 2 because of 2 at angle 0 is only one real part, imaginary part is 0 in this case. That's why real part is 2 only. This is a 2 plus V. You can use simply KVL like a DC circuit. In AC circuit also you can write the KCL and KVL. And care about the imaginary term. How can you return imaginary term, and how you add the imaginary term, how you add the polar form. Okay.
Yes, sir.
Yeah. J term is simply 90 degree, provide the 90 degree, minus of J term it will be minus 90 degree. Minus of J, it written it 1 by J also. If 1 by J is there, that means the minus of 90 degree provide the angle. After that, you have to simply add all of thing and find the voltage 1 plus J. 1 plus J, you know about the, if anything is written as like a Z is A plus JB. You know about the magnitude, all of you, A square plus B square, and angle theta is written as tan inverse of B by A, and this will be written as Z mod of Z at angle of theta. Zm magnitude I written as Zm at angle theta. Same thing I written this one. And this thing, if you write in sine term root 2, then this will be a root 2 is magnitude, this one is the angle, this is sine t plus 45. Let's try for the next question. For the circuit shown below, what is the resonance frequency f naught? Asking the resonance frequency in this circuit. Again RLC circuit, but not the simple RLC circuit. There is another term is given as dependent current source. Why current source? Because of the symbol of this one is the current. This is a current symbol. That's why this is the current source. It is plus or minus mentioning. That means this is the voltage source. This is a current source in a rectangular box. Rectangular box is mentioned. That means the dependent current source. Okay. Means this circuit is written as a inductor and a capacitor parallel with the dependent current source, means Z input impedance. So 10 ohm, 1 millihenry. You can write, I write it simply J omega L in place of J omega value of this one. This will be 1 upon J omega C V1 by 2. This is the V1. If any circuit dependent source is there, then how can you find the value of impedance, or you can say the Thevenin impedance, ZTH. ZTH you can find by VI method. Simply in this case also you have used AC circuit, the AC circuit V and I. Because V at angle 0, it means same as V and I. You have to use this one and find the value of V by I. This is the impedance, impedance. Okay. Here you, you can transform this one current source into voltage source. This current source you can transform into voltage source. How can you transform? Simply multiply this one current source into impedance is voltage source. Then after transform the sources transformation, then this will be RL, this C, then this is makes the voltage source when dependent voltage source, This value is voltage V I. This will be 10 ohm, or I can say R 10 ohm plus of minus V1 j omega L. This will be same. Impedance is not changed, only the sources change. Then what is the source? This one. This will be V1 by 2 into impedance is 1 upon j omega c. This will be a V1 divided by 2 j omega c. If we j multiply the upper side, this will be V1 j minus of V1 j divided by 2 omega c. Okay, I write this one. V1 multiply this one j 2 omega c. Okay, write V1 j 2 omega c. Simple circuit, all of the connected in series. Then simply use a loop 1, apply the KVL. KVL in loop 1. I started from here. This will be V, then minus of V plus this is V1 plus I into j omega L plus of I into 1 upon j omega c plus this voltage V1 divided by of j 2 omega c is equal to 0. What is V1 in this case? V1 you can say resistance multiply your current, it means 10I. You can put the value V1 as 10I, and you can send this one to right side. That's why this will be V is equal to V1 is 10I plus this will be a j omega L into I plus 1 upon j omega c into I plus this will be 10I divided by f j 2 omega c is equal to 0. You can take a common as I is common, then this will be 10 plus j omega L plus 1 upon j omega c plus 10 by j 2 omega c. This will be V by I, then this will be 10 plus j omega L. 1 by j is, you can say, minus of j by omega c. This will also minus of 10 divided by 10j, or you can say j10 divided by 2 omega c. At resonance, know about the at resonance imaginary part 0. This all is the imaginary part, because of 10 plus j you can take a common omega L minus 1 upon omega c minus 10 by 2 omega c. Okay, we take imaginary part 0. Imaginary part is this one, omega L minus of omega c minus of 10 by 2 omega c is equal to 0. Here omega L is equal to 1 upon omega c minus of plus of 10 by 2 omega c. Take LCM here, 2 omega c. This will be 2 plus 10 is equal to 12 by 2 omega c. It means this will be a 6 by omega c. multiply omega here, that's why this will be omega square is equal to 6 by LC. That means omega is under root of 6 by LC, or you can say frequency f is equal to omega is 2 pi f, then f is equal to 1 upon 2 pi into root of 6 by LC. Okay, because of the virtual calculator, don't put the value of L and C before till this one, before this one. This expression you have to use the calculator at once, only once. Put the value of L and C, find the frequency. If you put the value of L and C here, then what happening? All the calculation you have to take by using a calculator. That's one taking the long time to solve this question, this type of question. That's why to uh, save the time, use as use as a symbol L and C and R, and goes to like as minimum as possible. That's one f is equal to 1 by 2 pi, in this case 1 over c by 6 by LC. Then now put the value of L and C. Now simply you can put the value of L and C and find the frequency. 1 upon 2 pi root of 6. What is the value of L? L is given as 1 millihenry and C is 15 nanofarad. So 1 millihenry, it means 1 into 10 to power of minus 3 into 1 50 nanofarad, 50 into 10 to power of minus 9. Okay, it means 1 by 2 pi root of 6 divided by 50 into 10 to power of 10 to power of minus 12. 12, it means half of this one is outside. 10 to power of minus 6 are outside. This will be 6 by 50. Now you use the calculator to solve this. 6 by 50 under root, this one is 0.346 divided by 2 pi. 2 pi is 6.28. This will be 0.055 divided by 10 to power 6 into 10 to power of 6. 10 to power 6 is written as 10 to power 3 and 10 to power 3. This will be K. Make the K hertz. This will be hertz. Then frequency will be 55 kilohertz. Okay.
Yes, sir.
Simple resonance frequency. You have to find the impedance and you put the imaginary part at 0. Because of the resonance condition, only real part is there, imaginary part is 0. Put the imaginary part 0 and then find the frequency.
Sir, for exam,
Yes,
75 percentage coming from the assignment, sir.
that may be possibility.
Okay, sir. One more doubt, sir.
Yes,
Every week, you mentioned not to be evaluated. That part also, the question will come.
which one question?
Apart from the assignment, for
Yes,
practicing purpose, you are given some questions, right?
yes, yes, yes.
From that also we expect.
It not can say the exact same question, but this that type of question may be asked.
Okay. Okay.
I think it will be many question same like that, but not exact value.
Okay, sir.
Yeah. I think this type of question, a resonance frequency, asking the it may be chances to find resonance frequency. It may be one or two questions from this one.
Thank you, sir.
Resonance frequency and Thevenin impedance. This type of question is a common question. It may be asked.
Thank you, sir.
Yeah. Two voltage source have equal EMF and the phase difference is alpha. Okay. Okay. When they are connected in series adding, the voltage is 200 volt. When one source is reversed, the voltage is 15 volt. Then the value of EMF and phase angle respectively. Phase angle मतलब same alpha. Phase angle difference. There are two EMF and there is a phase difference is alpha between them, but the magnitude is same. If they are add in series, both are adding in series only. Means two EMF, one EMF, two EMF. You can say this one E1, this is E2. If you would take this one is a 0 degree, then what is the second one? Alpha, because of the phase difference between them is alpha. Then one is 0. If you let as one is 0, the second one is alpha. If you add this, the total voltage of E equivalent is okay. But in this case, given as E1, E2, this is E1 and E2, both have magnitude is same. It means E at angle 0 degree, E2 have E at angle alpha. Only phase difference is there. Magnitude is same. Yeah, have equal EMF. It means magnitude is same. Only phase difference is there. There are two conditions to add them. In adding, if series adding, if you add in series, that time the voltage is 200 volt. How can you support the two voltages? In phasor diagram, you can say if E is equal to 0 degree, then 0 degree is denoted like 0 straight line horizontally is 0 degree. Means this one is the 0 degree. If there is a vertical line always mention that 90 degree, like that. If 0 degree is there, then you can say this will be E1. Which one is E at angle 0 degree? Second one is E alpha. It will replaced by the alpha degree. This is the E2 replaced by E at angle alpha. It means the angle between them is alpha, same magnitude, and the difference between them is alpha. What is the this is the phasor equivalent, and this is E equivalent, and you have to find E equivalent is given in this case is 200 volt. Magnitude of this one is given 200 volt. Two vector adding, you know about this one, that one, root of E1 square plus E2 square plus of E2 square plus 2 E1 E2, and phase difference between them is alpha. E equivalent is root of this one. You know about the adding up two vector, because both are the vector. Equivalent to, in this addition condition, this will be a 200 given in the question. Then this will be a 200. E1 is E, magnitude is 1, E square. Second, E2 also E, same magnitude. 2 E is E square also here, cos alpha. You can take a E square common, then outside is E, because of root of E square is only E. 1 plus 1 plus 2 cos alpha. 1 plus 1 is 2 E root of 2 plus 2 cos alpha. You can take a root of 2 common. This will be E root 2 and root of 1 plus cos alpha. Equation number first. First condition is completed. Second condition, when the one source is reversed. One source is reversed, it means this direction is reversed. E1 suppose same, E2 is reversed to this direction. Reversed, it means this will be simply reversed to another direction. In that case, in second case, if this is the E1, okay, then first time E2 is this one, in that case E2 is this one.
So now we can put minus E2, right, sir?
Yeah, you can put the minus of E2, or you can take the angle. What is the angle? Alpha. That time angle is 180 plus alpha. In this case 180 plus alpha. In this case equivalent, or you can put the value of E2 is minus. Both are the same condition. Because of 180 plus alpha, cos is minus. E1 square plus same E2 square plus 2 E1 E2 cos 180 plus alpha. Here you can simply put cos alpha and put the value of E2 is negative. Both are the same. Same E common, this will be 15 in this case. E root of 1 plus 2, this will be cut one, cos 180 plus alpha is minus of cos alpha. The 2 is 2. It means this is a 50 E root 2 and root of 1 minus cos alpha. Equation number second. Simply divide the
Sir,
equation first.
sir, if I consider E2 is minus,
Yes,
okay, so
that
E1 square and E2 square is cancelled,
no,
okay,
E2
but
is
the value, numerical value is equal, but the direction is opposite, right? So E1 square and E2 square is cancelled, and we put minus 2 into E1 square into cos of 180 minus alpha.
no. You can't conclude all of things. If you put the value of E1 negative, E2, suppose E2 is minus of E, na?
Yes, sir.
The minus of E, that means if you square of minus of E, that's one only E square, not minus of E square.
Okay, okay, sir.
Yeah, that's one E square here, E square here. This will be minus 2 E1 E2. If you put the value of minus I, we don't no need to take 180.
No,
Anything
sir.
180 is
Actually, in the
negative.
opposite direction means the previous case with between E1 and E2 is alpha.
Yes,
Okay.
yes.
If you are opposite direction means total degree is 180. From that we have to subtract the alpha. So the remaining is 180 minus alpha, no?
Both are the same. 180 minus alpha, 180 plus alpha. What 180 minus alpha, it will be this one angle.
Sir, yes, sir. That's
This
what
is
I'm saying.
180 minus alpha. You can put the
Yes, sir.
180 cos 180 minus alpha is the same. Minus cos alpha. Both are the same.
Okay, sir.
Cos 180 minus alpha. This will be also minus cos alpha. If you put the E2 as negative, that means this E2 include the 180 degree plus alpha, minus include the 180 degree. If there is a negative, it means 180 degree. Why? Because this one is with 0 degree, 180 degree is direct negative. This is the 180 degree. If there is a E, then this one is a minus of E. You can put any one only, or you put the 180 degree, or you put the minus of E. Don't put both minus of E and 180 minus alpha. Don't put both. Only put the only one, or you can change the angle, or you can change the value, because both are the same.
Okay, sir.
Yeah. Now you can divide 1 divided by 2. Equation number 1 is 200 divided by 15. This will be 200 divided by 15 in
Sir,
left hand side.
excuse me, sir.
Yes,
So
yes.
still, I have confused. You have said that either you can change the angle or otherwise consider negative sign. How it is possible, sir? Because, oh, okay, you are saying that the direction is not equivalent to scalar, right? So direction consider means without consider the angle, or if you are consider the angle, no need to consider the negative side.
Yes, this one is the direction. Negative sign denoted the direction only.
Yeah, yes, sir, yes, sir.
Once you put the negative, it means this one is the opposite direction. Then no need to put the angle also. Angle also mention only the negative direction, because of minus of E, it means this will be E at angle of 180 degree. Already mentioned 180 degree.
But we consider the J term, right? J means angle 90 degree.
Yes, yes.
But here you are saying that 180 degree minus means 180 degree. How it is possible, sir?
J is 90 degree. J square is 180 degree. And J square is minus of 1.
Yeah, yes, sir, yes, sir. Thank you, sir. I
Then
understood.
minus of 1, it means 180 degree.
Yes, sir, yes, sir.
Yeah. E root 2, this will be same E root 2 and root of 1 plus cos alpha here, and denominator side in equation second E root 2 and root of 1 minus cos alpha. This is cancel out to each other. 200 divided by 15, this will be 13.33. 13.33 is equal to, you can take whole root. This will be 1 plus cos alpha divided by 1 minus cos alpha. Here you can square them both sides. This will be 177.77, 1 plus cos alpha divided by 1 minus cos alpha. You can transfer this one, 177.77 minus of 177.77 cos alpha is equal to 1 plus cos alpha. It will be 176.77 is equal to 178.77 cos alpha. Cos alpha is equal to 176.77 divided by 178.77, 0.988 cos Now we can take the cos inverse of this one. Alpha is equal to cos inverse of 0.988. Alpha is equal to, this will be 8.59 degree. Okay, 8.59 degree. Then what is the value of E magnitude? You can put the alpha in any one equation. From suppose equation
Yes, sir.
number second is 15 is equal to E root 2 root of 1 minus cos alpha. 15 is equal to E root 2 root of 1 minus of cos alpha. Put the value of cos alpha here. 15 divided by of root 2 root of 1 minus cos alpha. Cos alpha is this one, 0.988 is equal to of E. That means E is equal to 1 minus 0.988 under root of this one into root of 2 inverse into 50. This will be a 100.06 volt. Okay. In the given options, this will be 100 volt, 8.58 degree. This one. Option B is correct. Okay. Next question. The circuit shown below is operating at a frequency of 500 kHz. Bandwidth is equal to 20 kHz. The resistance of the coil is 5 ohm. Then the dynamic impedance of the circuit in kilo ohm. Dynamic impedance, it means the impedance at resonance is the dynamic impedance.
Sir, for a dynamic impedance, any formula is there?
Yes, there is a formula, but you have to find because of the can't because the simple circuit is given RLC, RL, series or parallel circuit, then you can directly say that this is the dynamic impedance. In series circuit, this will be R only because of the XL is equal to XC. Cancel out, only R is the dynamic impedance in series RLC circuit. But if circuit is another thing beyond of the RLC series and parallel circuit, that condition you have to find the impedance and put the imaginary term at 0. After that, find the frequency of that case, then put that frequency in real part. Real part is the dynamic impedance only. Dynamic impedance at a resonant frequency, it means the imaginary part is 0, only real part is there. Then you have to find the value of real part.
Yes, sir.
Yeah. In this case, frequency is given as 500 kilohertz. Okay. What's the impedance in this case? If you use direct formula, that may be chances are you get the different circuit. If the different circuit is there, then you can't use direct formula because of in that case maybe chances to differ to your circuit impedance, dynamic impedance. This will be R, this will be J omega L, this is the J omega C. Value of omega L and omega C is not mentioned. You have to find from this one. Sorry, resistance is given as 5 ohm. In this case, what is the impedance? total impedance Z series R plus j omega L and parallel with 1 upon j omega c. This is the impedance R plus j omega L multiplication of,
Sir, in the capacitor, we have to mention minus j omega c, right?
oh sorry, this one is the 1 upon j omega c. Sorry for this.
Yeah.
I am mentioning this one here, but by mistake I putting the j omega c. This one divide by of summation of all thing all plus R plus j omega L plus 1 upon j omega c. Take the LCM in this case. This will be R plus j omega L into 1 upon j omega c divided, put the take LCM, this will be j omega RC, this will be j square is minus half 1, this will negative omega square into LC plus half 1 divided by of j omega c. Omega c is cancel out. Okay, then z is equal to R plus j omega L divided by of 1 minus of omega square LC plus of j omega RC. You have to separate the imaginary part and real part, but in this case you can't say directly what is the real part and what is the imaginary part. In this case you have to simply multiply a negative term is here from this one, 1 minus of omega square LC minus of j omega RC, same thing, divided by 1 minus of omega square LC minus of j omega RC. You multiply R here, then this will be R 1 minus of omega square LC. Okay, sorry. Then this multiply by R j here minus of j, this will be omega R square C multiply of this one is j plus of j omega L, then this one is the minus, yeah, put the value of j omega L 1 minus of omega square LC, this omega L into this one, and that side this one into this one is minus as will be plus, because of the j square is plus minus of 1 minus of this one is plus omega square RLC. Divide by the all of thing 1 minus of omega square LC whole square plus omega RC whole square. Now you can take the real part together and imaginary part together. Real part in this case is this one. This one is the real part. This will be R 1 minus of omega square LC plus omega square RLC is the real part, and divide by of same 1 minus of omega square LC square plus omega RC square. Then first take the value of J here. This is the J positive term here. That's what I recognize the first this one omega L 1 minus of omega square LC divide by of minus of omega square omega R square C divide by of same 1 minus of omega square LC square plus of omega RC square. At resonance, imaginary part is 0. Imaginary part 0. Put the imaginary part as 0. This will be omega L 1 minus of omega square LC plus of omega. Sorry, this is the negative. That's why this is the negative. Minus of omega R square C divide by of 1 minus omega square LC plus omega RC square is equal to 0. That means this will be omega square. We multiply as 0, all of the value is 0. 1 minus of omega square LC minus of omega R square C is equal to 0. That means omega L 1 minus of omega square LC is equal to omega R square C. Omega is cancel out. 1 minus of omega square LC is equal to, this will be R square C by L. Omega LC minus of this one is equal to, this will be R square C by L minus of 1. This will be R square C by L minus of L. So the negative term, multiply of negative here. This will be omega square LC is equal to L minus of R square C divided by of L. And what is the omega? Omega is equal to multiply by LC in denominator side time, and then take a root L minus of R square C divided by of L square C. Or same thing you can say this will be 1 by LC minus R square by L square, R by L whole square. This is the frequency in this case, resonance frequency. This is the resonant frequency in this case. If the R, L connected across with the capacitor, this type of circuit is there. In that case, the resonant frequency is this one. In series RLC circuit, only this term is there. 1 by under root LC, you know about this one. In series circuit, RLC series circuit, resonant frequency is 1 by root of LC. Only this term is there. This one is 0. Because why? If the resistance is 0. Parallel and the same 0. R is 0, then this will be only that one. Same to same. RLC series are parallel. But in this case, there is a resistance and inductor connected across the capacitor, and that's why the resonant frequency is this one.
So this formula is not suitable for this problem, sir.
Which one? This formula.
Yes, sir.
This
Root
one.
of.
This one is suitable for this one, na? This circuit.
Okay, okay, sir.
Yeah, because I draw the all of thing this frequency by
Same
using
circuit.
this circuit. Now you have to find the dynamic impedance, Z dynamics. Know about Z dynamics is the real part of this. Real part is this one. This will be R. Real part is R minus half omega square R L C plus omega square R L C divided by of 1 minus half omega square L C plus of omega R C square. Actually, this thing is same to same. That's why it will cancel out. Both are the same. If you multiply by R here, then this will be R minus of omega square RLC. This is omega square RLC. Both are cancelled out. Only this part is there.
Sir, no, sir. R into. Oh, after multiplying, it will be same. Okay, okay, sir.
Yeah, yeah. After multiplying, it will be same. Then this will be R divided by of 1 minus of omega square LC whole square plus of omega RC square. We have to put the value of omega in this case. This will be also omega square.
Sir, how it is possible? We have to must know this formula, right? During
Yes,
the
yes, yes.
examination. Otherwise, we can't solve within 1 minute or 2 minutes.
Yes, in this case, simply I draw the all of thing by your understanding. But if you know about this one, the formula directly you can put this type of circuit. We have to learn the 3 to 4 type of circuit. When this one is there, RLC circuit, parallel circuit, like that. If there is asking something, directly you can put the formula and find the answer.
Okay, sir.
Hmm.
Sir, if you don't mistake me, like that, what are all the formulas we can use for the whole 12-week assignment? Is it possible, sir? Because for in between, every problems are different, not same.
Yes, yes, yes.
Is it possible, sir?
That's how you draw all the formula with every question. Because of the circuit is different. If the circuit is same, then you can use the directly formula.
Oh, in the downloaded video, it's available, right?
Yes,
For
yes,
yeah, you mentioned that formula also.
yes, yes, yes.
Okay, sir.
If you solve this one thing, na, you put the value of omega, then same thing it will be L by RC only. Simple formula L by RC. If the RL circuit is there with a capacitor, and this is the dynamic impedance is simply L by RC, and the omega frequency is root of 1 by LC minus of R by L whole square. Okay, we have to
So
solve these
no
two.
need to calculate omega, right? Directly we can put this formula L divided by RC.
Yes, but in this question the value is not given L and C.
Okay, okay.
In that case, something is given in the question. Given as bandwidth equal to 20 kilohertz is given, and the unit frequency is given 500 kilohertz. Then you have to choose this thing. Bandwidth is given. Bandwidth, you know about bandwidth is a operating frequency or unit
Yeah,
frequency
F2
divided by
minus F1.
quality. Yeah, divided by a quality factor.
R divided by 2 pi LC, sir.
Yeah, yeah. And Q in this case is omega L by R. No, what Q is omega naught L frequency, operating frequency. In this case, you can say this will be F naught into R divided by F 2 pi F naught into L. It means simply R by 2 pi L. In this case, R is mentioned as I think 5 ohm. Then we can find the L value. Bandwidth is given as 5 kilohertz, 20 kilohertz. That this will be 20 into 10 to power of 3. R is mentioned as 5. Then this will be 5 divided by 2 pi into L is equal to 20 into 10 to power of 3. In this case, you can find the value of inductor L. Well, this will be 5 divided by 2 pi into 20 into 10 to power of 3. You can solve this one. This will be a 39.8 micro Henry. Okay. And another thing is given as frequency. The other frequency is given as 500 kilohertz. This will be 1 by 2 pi same root of 1 by LC minus R by 2 R by L square. In this case, R is given in the question, L is calculated here. You have to find the value of C. We have to put a 2 pi into 500 into 10 to power 3. We have to square up this one. That will be 1 by LC minus of R square by L square. Find the value of R by L whole square. But with this one, then this will be 1 by LC is equal to 9.875 into 10 to power of 12. That case, in this case, what is value of C? C is 1 divided by of L into 9.875 into 10 to power of 12. That means this will be 2.54 nanofarad. Then what jet dynamics is equal to simply L by RC. L is 39.8 micro into 10 to power of 6 minus of 6 divided by R. R is 5 into 2.54 into 10 to the power of minus 9. This will be 3.128 kilo ohm.
Sir, for this problem,
Yes.
nearly it will take 20 minutes, sir. Sir, how it is possible in the examination, sir?
At,
Because even though if you know the formula, we can substitute that value of L separately and using that we can use another formula for C, finding the C also. Sir, this type of problem taking more time, sir, and also we are not using the physical calculator.
Yes, yes, yes.
Sir, consider, sir, please, sir.
Okay, okay, no problem. But I think in the question, they will not asking all of things like that. It maybe provide some values, only one or two values there to find, not all of them. This is the simple sample question. That's why I'm starting from the zero to that one. If you know about the formula, simply use the formula uh, frequency and dynamics impedance. Use this one and started from this one. Then no need of this all thing. This all thing only for the understanding. Use this thing. ZY the
Okay,
log
sir.
R.
Okay.
Maybe question is given as a capacitor, then you have to find only inductor. Inductance value you can directly put this formula. R by 2 pi L is the bandwidth. Yeah, you can start it from this one. Bandwidth is operant frequency divided by a quality factor. Then you can find then simply L value, then put the value of L, R in the question, and see and call the final answer. Jet dynamics. Or it may be asking only this one, operating frequency. Then put the value all of the, you can find the frequency. You're not asking like that in this examination. In the examination, in 1 marks type, this is the length expression of the, and 5 marks, 10 marks like in exam, in theory exam, not at MCQ. Okay. Okay, everyone. I
Okay.
think I want to stop here.
Okay, sir.
Yeah. And revision class is on 16th of October and last
Oh,
week is there.
16. Okay, sir. Sir, you can cover all
All
week
topic.
assignments, sir.
Yes, yes. All topic is there.
Okay, sir. Thank you,
Okay.
sir. Thank you very
Okay.
much.
Thank you. Thanks to all.